My dear students, let us discuss an essay type question from current electricity, which is very, very important. In this question, there are two parts. One is give the statement of Kirchhoff's laws for a given network and obtain the balancing condition for a Wheatstone bridge. Wheatstone bridge is nothing but the combination of four resistors P, Q, R, S connected through a galvanometer to a battery as shown in the diagram. There are two laws. The first law is called Kirchhoff's junction law or Kirchhoff's current law. In this, we consider a junction through which many currents are going or at which many currents are meeting. So this is called as the junction. So at this junction, many currents are meeting. Let us say a current is coming and few currents are going away. Let us say this is I1, this is I2, this is I3, and this is I4, and this is I5. Given junction, the algebraic sum of all the currents is 0. That means the amount of current entering the junction must be equal to the amount of current leaving the junction. What are the incoming currents? I1 plus I2 plus I5. What are the currents leaving? I3 plus I4. The algebraic sum of currents at this junction is 0. So I1 plus I2 minus I3 minus I4 plus I5 is equal to 0. In the exam, if you write sigma E is equal to 0, you will get 1 mark. Kirchhoff's second law. It is also known as Kirchhoff's voltage law, or it is also known as loop law. In this, we take a loop. Our voltage drops near the resistors and voltage sources are nothing but the EMFs of the cells. So within a loop, in a given loop, the algebraic sum of voltages is 0. It is nothing but the amount of voltage drop is equal to the amount of EMF supplied by the electric cells. In a given closed loop, the algebraic sum of voltages is 0. This is a Wheatstone bridge. We apply two laws. At B and D junctions, I apply Kirchhoff's first law. We adjust the values of P, Q, R, S, that is the four resistors, such that the current going through the galvanometer becomes 0. In that case, the Wheatstone bridge is said to be balanced. Now I am applying first law. So first law for junction B. So at junction B, I1 is the incoming current and I3 is the outgoing current. This is the equation number 1. At junction D, the incoming current is I2 and the outgoing current is I4. So this is the equation number 2. Now I apply Kirchhoff's second law. Take the loop A, B, D. This is the first loop. In this loop, there are no electric cells. So there is no question of EMF. So only voltage drops. So voltage drop across P is given by, from the formula V is equal to IR, voltage drop is equal to current times resistance. So this is I1P. So anyhow Ig is 0. So no need to consider. So you are going in clockwise direction. Here the current direction is opposite. So you have to take minus. So this is I2R. This must be equal to 0. I1P is equal to I2R. Now I apply Kirchhoff voltage law to the second loop, second closed loop, that is BCD. You are going in the same direction, that is the clockwise direction. Current is also going in the same direction. So that is positive, I3Q. And while coming back, here the directions are opposite, the chosen direction and the actual current direction. So this is minus I4S is equal to 0. Right, I3Q is equal to I4S. So this is equation 1, 2, 3, 4. Divide the equation 3 with 4. Then I will get I1P by I3Q is equal to I2R divided by I4S. From equation 192, I1 is equal to I3. So these two gets cancelled. Next, I2 is equal to I4. These two gets cancelled. So you will end up with P by Q is equal to R by S. This is the condition, or this is the balancing condition of a Wheatstone bridge. If you arrive at this point, you will get 8 marks. State the working principle of a potentiometer. Explain with the help of circuit diagram how the EMFs of two given cells are compared by using the potentiometer. A potentiometer consists a wire, a manganese wire of length 10 meter. There are two circuits. This circuit is called primary circuit and this circuit is called secondary circuit. Primary circuit consists a standard electric cell. Its EMF is E0 and it is connected to a rheostat and the end of the wire is connected. So, the total length of the wire, let us say AB. The secondary circuit consists two cells. So, cells of EMFs, let us say E1 and E2. And these are connected to a two-way key. And this is connected to a galvanometer and to a jockey, J. Potentiometer draws current from the standard electric cell. It is not going to steal any electricity from these two. So, working principle of potentiometer. The potential drop is directly proportional to the length of the wire. So, when I move the jockey from A to B, the potential drop across the manganese or constant and wire changes. In order to compare the EMFs of two cells, let us connect the first cell. In order to connect the first cell to the secondary circuit, I connect the two-way keys such that the key 1 and 3 are connected. So, in this way, only E1 is connected to the secondary circuit. I move the jockey from A to B till the null deflection is appeared in the galvanometer. From the basic principle of potentiometer, the potential drop E1 is directly proportional to balancing length L1. I repeat the same by disconnecting 1 and 3 keys. Now I connect 2 and 3. So current goes through the E2 only. So E1 is disconnected and E2 is connected. Now I repeat the same. So the balancing length in the previous one is L1. Now when I move the jockey from A to B, in the second case, let us say the balancing length is L2. So E2 is proportional to L2. So whenever there is a proportionality relationship, we can put a constant. Let us say that proportionality constant is K. So I can write this equation as E1 is equal to KL1. Similarly, E2 is equal to KL2. So 1 over 2 will give you E1 by E2 is equal to L1 by L2. It is enough to compare the EMFs of two given electric cell. So there is one more extension question on potentiometer. State the working principle of potentiometer. Explain with the help of circuit diagram how the potentiometer is used to determine the internal resistance of the given primary cell. So every cell consists some electrolytes, some metal plates and some other wires. So because of these electrolytes and wires and chemicals, there will be some internal resistance. That resistance is called internal resistance and it is indicated by small r. This is the basic circuit of a potentiometer. In the secondary circuit, we connect it to a unknown electric cell. Jockey is moved from A to B till the galvanometer reading becomes 0. Let us say the balancing length in this case is L1. So, E is proportional to L1. This is the first one. Next step, what I do, I connect a known resistance in parallel to the unknown electric cell. Let us say the resistance of this known resistance is capital R. Because of the combination of electric cell and the external resistance, the potential will be V. Now repeat the same experiment, move the jockey from left to right till another balancing length L2 is obtained. So V proportional to L2. So these are the two equations. Written as E is equal to some KL1 and V is equal to some KL2 where K is a proportionality constant. Divide one over the other. So this is E by V is equal to L1 by L2. But we know that E is equal to I times capital R plus R and V is equal to IR. You substitute these two. To R plus R divided by IR. So II gets cancelled. This is equal to L1 by L2 plus R by R is equal to L1 by L2. R by capital R is equal to L1 minus L2 by L2. Right, R is equal to R times L1 minus L2 by L2. R is known value, L1 and L2 are known values. So we can find the internal resistance of a given electric cell.